Hey everyone, my name is Venelin, and in this video we're going to have a look at DeepSeek Coder. This is an open source large language model by DeepSeek AI that the authors claim that can outperform ChatGPT or GPT 3.5 on coding tasks. We're going to have a look at what the model is, how it was trained, where you can get it, and then we're going to try it out on a couple of coding tasks. Let's get started. The DeepSeek Coder model was trained on 2 trillion tokens, and about 87% of that was code, and then about 13% of that was natural language in English and Chinese. The models are provided in different sizes, and as you can see, the authors are describing sizes from 1 billion parameters to 33 billion parameters. Another very important thing is that these models have a very large window size, and there is about 16k of tokens that you can put in within those models. So another important thing is that there is also this fine-tuned version of the base model that is called DeepSeek Coder Instruct, which was additionally fine-tuned with 2 billion tokens of instruction data. So this is pretty much a summary of what you get with these models, and this is the UI that we're going to try in a bit. But the more important part here is that actually the performance of this model, at least according to the others, is amazing compared to other open large language models. So here they're comparing the DeepSeek Coder model to Code Llama, the 34 billion parameter model, which was the largest one available. And it says that this DeepSeek Coder model is actually performing much better. You can see the percentages here, roughly 8 to 10% better performance on different benchmarks. And then the authors also claim that the DeepSeek Coder Instruct is performing better than GPT 3.5 Turbo on human evaluation dataset. So here is a breakdown of what you get with this model. And you can see that in red, here is the DeepSeek Coder model. And you see that the model is performing vastly better compared to even Code Llama and even the other star coder models, etc. So at least it looks to me that especially on the Python performance part, you get much better results compared to open large language models that we have. And in this video, we're going to actually try the Python coding capabilities of this model. So here is a breakdown of what the model can do. And you can see that the DeepSeek Coder base model is outperforming pretty much everything across the board in this table, and is performing much better on all of the evaluation examples. And here the instruction tuned model is compared to GPT 3.5 Turbo, GPT-4, and you see that actually the 33 billion parameter model is performing very well compared to the ChatGPT model, and it is outperforming it pretty much on everything except for the MBPP benchmark, but it is very close. And here are the results for GPT-4. And as you can see, the model is not that far off on those benchmarks as well. So I would put it somewhere between ChatGPT and GPT-4, like right in the middle. There is a GitHub repository that is associated with the model. And here you can see the similar graphic that we had within the report on the official page, as well as the tables from there. But here they're describing some of the ways that they're using in order to generate the training data. And here you see that they're actually applying the same filtering rules such as the star coder data in order to filter their data sets. And this is pretty much the pipeline that they're using in order to get somewhat more quality coding data set. So here you can also see that the model is available from HuggingFace. And this is an example of how you can load the model right within the Transformers library. And the models themselves are under the DeepSeek repository on HuggingFace. And here you can see that the models that are available are ranging for 1.3 billion parameters up to 33 billion parameters for the instruct models. This is the official UI provided by the DeepSeek AI for the DeepSeek Coder model. And this is actually running the 33 billion parameter model on the left. And here I have a Google Colab notebook that is already running, and in it I'm going to execute the code that the model is actually providing for us. So let's start with something simple. Write a function in Python that calculates the square of a sum of two numbers. So this is very similar to what we had in previous videos, and let's see whether or not the model can do this for us. And here you see actually that the model is performing or doing the inference very fast, and I'm going to copy the code. You can see that actually the model is performing a very nice function, or outputting a very nice function, very succinct. Let's check the response. Let's check with the provided values, and you see that the output is actually correctly predicted by the model. For our next example, I'm going to copy and paste my prompt, and here it is. Write a function in Python that splits a list into 3 equal parts and returns a list with a random element for each sublist. So this is again very similar to what we had in previous videos. And here you see that the model is actually providing us with the function again, which is great. Let me just paste it in here. And let's try out the function. I'm going to copy the code for this one here. And I'm going to essentially run this just to make it a bit easier. Yeah, the output looks to be correct. Let's have a look at the function. First, the function is actually checking whether or not the list has less than 3 numbers, and if that is the case, it is providing a value error or raising a value error. Then each sublist length is calculated, which is great. The comments also help. Split the list into 3 equal parts, and this is done using indexing of the indexing of the lists. Then we have a random choice, and a random library or module is actually imported right here. So it appears to be working just great. Let's try something here. Yeah. So in this case, this doesn't appear to be working as expected. I was expecting that we get something like 1 and then 3 and then 5 or something like that, since the last element was this one. So not entirely perfect this function, but maybe my prompting was off as well. Let's try something a bit more involved. So here is my prompt. Write a function that generates an excuse when my girlfriend asks me to do something, like go to the mall or to the movies, but I only want to do some deadlifts and go for a walk. The excuses must use the personality of Dwight Schrute from the office. So this is the function that we're going to get. And again, you can see that the output is quite fast. And here is the final function that we get. Let's check it out. I'm going to paste it in here. So it even included a sample code. Let's execute this and actually generate an excuse. I'm afraid I can't do that right. I'm here to do my deadlifts and walks. All right, so it thinks that it is actually Dwight. I'm sorry, Dwight, but I'm not available. I'm here to put on muscle and take a stroll. Okay, so it didn't actually get what I'm telling it to do, but the code appears to be working just fine. I generated a list of excuses, and then it used the random choice function in order to get a single excuse. So I would say that the code appears to be working all right, but the prompt didn't get what we were asking about it. And just for completeness, here is the exact same prompt that I've given to ChatGPT, and you see that ChatGPT actually didn't want to provide any code that generates an excuse. So you can see that the response was heavily censored. So at least in that point, it looks like the open source DeepSeek Coder model is actually performing much better compared to ChatGPT is giving us. Next, we are going to try some LeetCode problems. And I'm going to start with something very simple. This is the two-sum problem, which is very easy, and I can attest to that. So I'm going to essentially copy this. And the problem is that given an array of integers and an integer target, return indices of the two numbers such that they add up to a target. So you might assume that each input would have exactly one solution. So you might not use the same element twice. I'm going to input this as a prompt. Add the solution, and I'm going to add that the solution must be in a class solution, since this is required from the LeetCode examples. And then the function and the method name should be toSum. Let's see what we get here. And keep in mind that these problems are widely available, and also their solutions are widely available on GitHub. So we might just be getting something that the model has completely memorized. And let's copy this. And let's, here is the funny or the easy part, I would say. We can essentially get the solution and then submit it. And you can see that the actual solution was accepted. So this even beats about 94% of the users with Python 3, since the runtime is very fast. Memory is not that efficient for this solution, at least. But yeah, you can see that the model is performing very nicely, at least on the runtime part, and the solution was also accepted. Let's continue with a medium problem. Find the winner of an array of game. Given an array R of distinct integers and integer k, a game is played between the first two elements of array. Each route the game we compare, the larger integer wins and remains at position 0. So essentially you are beating integers against each other. It is guaranteed that there will be a winner in the game, and then we have to return the integer which wins the game. So I'm going to essentially get the same thing as a prompt, but I'm going to again add the solution, and the solution must have the get winner. Okay. And yeah, you can see that it is performing the correct function. Let's get the solution, and immediately you see that the solution involves a while or a while's loop. So the solution should be performing pretty nicely according to the speed requirements. Again, this solution was accepted, and the runtime performance is amazing as well, 94%, better than all of the users. And then this beats 85% of the users on the memory requirements. So this one is very wide on memory as well. So this was a medium problem, as you can see. Find the array game. So at least until this point, if the models can solve easy and medium problems, you can actually use those types of models in order to solve problems for interviews. And some of the companies are actually asking just for easy and medium problems. Of course, hard problems is where the fun begins, I would say. So this is count of range sum. Given an integer array nums and two integers lower and upper, return the number of range nums that lie in lower and upper inclusive. Range sum is defined as the sum of the elements in nums between indices y and j inclusive, where y I is lower or equal than j. So at least from the description, you might notice that this should probably include some sort of binary search. But of course, this wouldn't be enough in order to solve this problem. So let's pass in the prompt, and I'm going to take the solution part. And here I want to have the count range sum. Let's see what we get. Again, this is a hard problem, so I wouldn't expect actually this model to solve it. I would be really impressed if it does this. And here is the output. This problem can be solved using a combination of merge sort and binary index tree. So yeah, merge sort and binary. The idea is to use the binary index tree to count the number of range sums that lie in a given range. Okay, it sounds really interesting. Okay, let me copy this. I'm going to add it and submit it. Let's see whether or not we have a solution for this. And actually, it did solve the problem. A couple of hours ago, I've tried the exact same prompt and the model didn't or wasn't able to give us a solution that can solve this. But as you can see, this is even solving a hard problem on LeetCode. And this is, I believe, a relatively new problem. I'm not so sure about that, but yeah, it looks that the solution is pretty involved. And I would say, let's check the output. In this solution, we first calculate the prefix sum of the array, so this makes sense. Then we sort the prefix sum and remove duplicates. Again, makes sense. We use binary index tree to count the number of elements that are less than or equal to a given number, since we want the low and high. For each prefix sum, we find the range of numbers that are within the range, upper and lower. Yeah, when we use the bit to count the number of elements that are within this range, finally we update the bit with the current prefix sum. So it's pretty involved, a way to use the binary index tree. And as you can see, it is actually using the bisect function in order to do some binary searching on parts of the array. So yeah, it appears that the model is performing very well on these types of tasks, and I'm pretty impressed with that. In my previous video, we've seen how we can use the AutoGen library to generate a SaaS landing page. And here I'm going to take the same prompt that I've used there, and I'm going to paste it in. So here we have built a landing page for SaaS. Let me just expand this. That creates chatbots using ChatGPT from a set of documents. Think of a name of the product, short tagline, add a form, and collect user email when the product is ready. Add an admin page that shows a table of added emails. Use Flask for the app, Tailwind CSS for styling, and SQLite tree as a database. So here is the outline of this model or this Flask application that we get. And it is also providing us with the index page and an admin page for the list of the emails, probably. And let's see what we get from the index page. You see that we are actually using SQLite Tree Connect. It is providing an email database for us. And then it is also showing the admin page. Then in the name or the main function, it connects to the email and creates a table for us. Then it is committing the code and then starting the app. So everything looks to be all right on a first glance. I'm not sure about the templates. Yeah. This is a very basic example. It doesn't include any styling or validation to make your application look professional and secure. All right. So the first thing that I don't see here is actually I want this to think of a name of the product in a short tagline. This is not included within this template. And this is the application that is running as a Flask application. You notice that it is actually running. So I'm going to use my email from before. And let's actually go to the admin page. And you see that the actual email has been stored right here. So on the Flask app, even though it is simple, it appears to be working just fine. Let's see if the DeepSeek Coder can create a very simple Flappy Bird game. So I'm going to input my prompt here. And this is the prompt. Create a very simple Flappy Bird game in Pygame. It should display the current score and the end the game when the bird is below the screen or hits an obstacle. So this is the output of the model. You see that it is actually adding the correct imports. It is initializing the Pygame framework. And then we have the width and the height probably of the screen. We have some bird speed, some gravity as constants. What the bird image? I'm not so sure about that. Yeah. So I wouldn't say that this is great since we probably don't have images. Remove the loading of the images from the game. Okay, so now it is using some shapes, which is much better. Okay, so this should work just fine now. And note that the input or the instruction is actually very well defined, and then the response is pretty good compared to what you might have with other versions. The bird is red and the obstacles are green. I got the code from the output, and this is it. I'm going to run the app now. And you'll notice that the bird is actually not falling down. The game is moving, but yeah, you see that the bird isn't falling down. So here is the prompt that I'm going to use. There is also no screen scoreboard. So it's going to fix this for us. At least it says it will. Okay, it adds the obstacles. And then it increases the score. Okay, so we can try the fixed version. And here is the result. You see that we have this scoreboard and the bird is actually falling down. And you need to press the keys. The obstacles are a bit far between each other, but at least otherwise everything is appear to be working. Let's try to hit an obstacle. Yeah, and the game ends. Honestly, I'm pretty impressed with the DeepSeek Coder performance. The model's inference speed is very good, at least on their webpage. The model is also available from the HuggingFace repository. You can download various models from 1 billion to 33 billion parameter models. We've tried the model on a variety of tasks, including the LeetCode easy to hard problems, and it was able to solve all those 3 problems on the first try, which was pretty amazing. And then we've tried the model on to create a Flask web app, which it did. It was pretty simple, but still it worked on the first try. Then we've tried to use the model to create a simple Flappy Bird clone game, and it did that on the first try. Of course, it wasn't perfect, and then we've provided some feedback that was vastly improved the game, in my opinion. So if you want to see more of this model, and probably we can use this model, for example, in some agent like library like LangChain or AutoGen, let me know down into the comments below. Please like, share, and subscribe. Also join the Discord channel that I'm going to link down into the description of this video. And I'll see you in the next one. Bye.